Good morning, everyone. Today, we've gathered here virtually to attend a colloquium on the topic reinforcement learning conducted by CS Department in association with Internal Quality Assurance Cell. Former First Lady of America, Abigail Adams once said, "Learning is not attained by chance. Must be sought for with ardor and diligence." So here, we presented with an opportunity to learn something new, something more, something exciting. So I wish everybody a great learning experience. Now, before we start, let's start this function with a silent prayer. Before we begin, I invite Ms. Sabita PC Ma'am, HOD of Department of Computer Science, for welcoming everyone to the seminar.
Respected Executive Director, Reverend Dr. Davis Chengnade, Chief Guest of the Day, Dr. Amin Kumar, our Principal, Dr. Matthew Poluke, Training Head of Technova, Dr. Manish Kumar Jain, dear colleagues and my dear students. A warm good morning to one and all. Today, we, Department of Computer Science, is conducting a colloquium on the topic reinforcement of learning. In this occasion, I feel happy to welcome you all. First of all, I welcome our Executive Director, Reverend Dr. Davis Chengnade, who always shows a special interest in the emerging topics of computer science. Welcome, Father.
Thank you.
Next, I welcome our Principal, Dr. Matthew Polokan, who is always busy with our academic matters. Welcome you, sir.
Thank you.
Next, I welcome today's Chief Guest, Dr. Amin Kumar, Technical Consultant, IBM Singapore. Welcome, sir.
Thanks.
Now I welcome Dr. Manish Kumar Jain, Training Head, Technova. I welcome, sir. Now I welcome our CTO, Mr. Ranjit M, and Program Director, Ms. Jaimol P. James, and anchor of the program, Ms. Anlin, second BSc CS students. Lastly, I welcome my faculty colleagues and our loving students to this event. Once again, I welcome you all. Thank you. Thank you.
Thank you, ma'am. Actor Milton Ball once said, "If opportunity doesn't knock, then build a door." Having opportunities does play an immigrant role in determining one's success. On that note, I welcome our Executive Director, Reverend Father Dr. Davis Chengnade, for the inaugural address.
Dear respected Dr. Amin Kumar, Technical Consultant of IBM, Dr. Manish Kumar Jain, Training Head of Technova, Dr. Matthew Paul, our Principal, HOD MS Sabidamis, Mr. Ranjit Moni, and faculty members, participants, and students. Today we are having a colloquium on reinforcement learning, a part of machine learning, here in Sahrdaya College of Advanced Studies. We know we are conducting lots of computer learning, especially AI from IBM through Technova. In this growing concern, we know we are here in Industry 4.0, and IBM has a rich history with machine learning, which discover, design, and develop advanced information technology and translate that into value-generated people. IBM's tutoring our students gives wide open opportunities in a digital world that in this 4.0. Machine learning is an important component of the growing field of data science. The use of statistical methods may classify or and cover insights data mining projects. This colloquium on reinforcement learning led by Dr. Aman Kumar gives a more opportunities to think about AI and its applications in the common livelihood. Reinforcement learning is the science of decision making. RL is an area of machine learning concerned with how intelligent agents ought to take actions in an environment in order to maximize the notion of cumulative reward. Reinforcement learning is one of the three basics of machine learning paradigms alongside supervised learning and unsupervised learning. Insight subsequently driven to make a decision within applications and businesses ideally impacting key growth in the metrics. As big data continues to expand and grow, the market demand for data scientists will increase, requiring them to assist in the identification of the most relevant business questions and subsequently the data to answer them. As we know, the students, I think they understand how the machine learning is important because it gives enterprise a view of trends in customer behavior and business operational systems and patterns, as well as supports the development of new products. Machine learning is entering essentially all data-based fields, and big data is omnipresent from private industries to government organizations too. So we should have the ability to analyze and combine large amounts of data from different sources as for these obvious applications. For that, this reinforcement learning will definitely help us. I wish all the success, and I welcome Dr. Aman Kumar to this colloquium, and I officially inaugurate this session. Thank you very much.
Thank you, Father. Next, I'd like to invite our beloved principal, Dr. Matthew Paul Uken, for principal's message.
Good morning to all. Distinguished Dr. Aman Kumar, Technical Consultant, IBM Singapore, resource person of today's colloquium on reinforcement learning. Reverend Dr. Davis Chengniadan, Executive Director, Sahrdaya College of Advanced Studies, and who has inaugurated the seminar. Dr. Manish Kumar Jain, Training Head, Technova. Ms. Sabita PC, Head of the Department of Computer Science. Mr. Ranjit Moni, Jaimol, Ms. and other faculty members of Computer Science. IQAC Coordinator, dear Ms. Anlin, Student Coordinator, and dear students of Postgraduate Department of Computer Science. It's my pleasure and privilege to stand before you and deliver a few words of blessings and felicitations on the colloquium Reinforcement Learning organized by the PG Department of Computer Science in association with Internal Quality Assurance Cell IQAC of the college. The Computer Science Department is the largest of the science departments comprising of BSc Computer Science, BCA, and BSc IT, and MSc Computer Science programs. In connection with the Science Day, the department has conducted Best Innovative Idea Competition, Logo Quiz Competition, and Digital Painting. The department also have conducted many seminars in the last academic year. I congratulate the head of the department and faculty members of the Computer Science Department and all the students for organizing this program. Let this colloquium enrich the students to the new world of computer science related topics. Dr. Aman Kumar, the resource person of today's colloquium on reinforcement learning. He is working with IBM Singapore as a technical consultant and subject matter expert for AWS and DevOps domain with more than 12 years rich experience as a technical consultant. I also thank Dr. Manish Kumar Jain, training head Technova, for being with us. I express the institution's gratitude to Dr. Aman Kumar for his willingness to share his precious time and vast knowledge with our young talented students of Sahrdaya College. I thank Dr. Manish Kumar Jain also for being along with us. I wish the colloquium all success. Thanking all, I conclude.
Thank you, sir. Now it's time for the moment we've all been waiting for. For today's event, we're blessed with a very resourceful and influential personality. To introduce the chief guest, I invite Dr. Manish Kumar Jain, training head of Technova.
Manish sir, Manish sir, Manish sir.
Hi, good morning, Father. Good
Yes,
morning,
sir.
everybody.
Yeah, good morning, Manish sir.
Hi, good morning. Yeah. So thank you so much for inviting me and my team member for this program today on the topic of reinforcement learning. And we are privileged to take the session for the participant. So in the topic, we are going to be discuss about different types of use cases of AI and machine learning in the context of the reinforcement learning. See, because the market is growing on rapidly in the current situation. If I talk about the job situations and other things, so all the companies, they are expecting something new from the student or something new from the, this the future engineer. So like here, the objective for today's webinar is that to give you the more idea about how companies are working on it, what type of implementation they are doing, what type of project they are having here, and what they're expecting from the student. OK, so now here the session will be taken care by my colleague, Dr. Aman, and he's working as a technical consultant and project manager for one Singapore based organization. So he will take the session for reinforcement learning. Yeah.
Thank you, sir.
Yeah. Thank you. Thank you so much. Thank you.
With great pleasure, I invite Dr. Aman Kumar for the technical session.
Let me announce something before starting the session. So hi everybody. Hi participant. Good morning. So I know that probably you're facing some more. You will get some more questions during the session, like how this is working, how this thing we can do. So I request you that you can type your question in the chat box. or you can type the question somewhere in the notepad. So once he will finish the session, then after this, we will give you some more time to resolve your question. Yeah.
Okay,
So,
sir.
and I appreciate if you will ask more question. Yeah. Thank you.
Sure,
Thank you so
sir.
much.
Sure, sir, will.
Yeah.
So welcome all. Good morning, Father. Good morning, everyone. Esteemed authorities of the college, esteemed institutional faculty members, and privileged team members. So all the participants, very welcome to the reinforcement learning models of today. So let's begin our session. So if in case you face any challenge, any doubts, please do not be hesitant. Please feel free to unmute yourself. Please feel free to put into the chats. So let's begin for our next level of the technologies that is going into the industries with the real-time industrial use case 4.0 reinforcement learning model. So if we talk about this reinforcement models, so every of the technologies is moving to the next levels. So that next levels, there would be a driverless cars, the driverless drones, robotics. The agents would be helping, these machines would be helping our mothers to cook the food, for washing the clothes, and all the supervised model of reinforcement learning would be imposed with the AI, machine learning, and deep learning approach. So let's begin with some of the entities, how exactly the things worked on. So the first model, the AI, the artificial intelligence. The artificial intelligence, as you know, the computers mimic the human's language. They would be the logics of the Mark Zuckerberg, the logics of Sundar Pichai, the logics that is going into the machines so that 99.999% of the career success rates of the company's growth rates with the agile mechanism, with the latest developmental operation tools, with the machine learning's operations, AI ops, that is the outer circle that is going with the AI approach. Then comes the inside, how the machines would talk to each other. So there are different agents, and the barrier is the communication. The communications that includes the statistical approach, the mathematical approach, that the logics, the algos, the algorithms that would include the deep learnings, reinforcement learnings, and performing the next level of deep learnings approaches. So here we have the FANG companies, the Facebook, Amazon, Netflix, Google, the large emerging companies, the startup companies, they are all using the next level of the emerging technologies with the 4.0 approach, where the image recognitions, the speech recognitions, how we speak it, the speak synthesis markup language, SSML, Alexa, how the Alexa is talking, how Google's assistant or the Apple's Siri, they would be communicating. So they are using the deep learning reinforced model where the algorithms are used to train, to develop, to code, to build the image recognition, the voice recognition, the digital media analysis with the neural network models. So there is a large amount of data that is known as a big data, and how in the big data machine learning approaches that is going there. So the next level of the products that would be coming into the emerging markets, the driverless cars, the driverless drones, the Jetsons race cars, the drones, the industrial UAVs, that is the next level of the technologies that would be coming. And here you would be coding, testing, building, trying to the next levels of the reinforcement learning. So how exactly the bigger architecture looks like? So here we have the environment which is concerned with the reinforcement agents, the reinforcement robots, the reinforcement machines. They would be talking to the simulator. They would be talking to the simulator, and the simulator IQAC robot simulator. It is one of the use case, that is the NVIDIA chips are using it. That is how the embedded VLSI chips have been imposed onto the machines with the cell operations, with the AI operations, onto the cloud-based technologies with the virtual Jetson, and communicating with some frameworks, the PyTorch frameworks, the Metaverse frameworks, the Google's TensorFlows, the Keras, the TensorFlows, Microsoft's cognitive toolkits, and integrated with the OpenAI gym-based architecture. So in nutshell, the Industrial Revolution 4.0 has a couple of technologies immersed with the reinforcement learning, and where the machines would be building a logic, would be predicting it, would be telling that what would be the best use case scenario. So they are using some approaches onto the agile based environments. So the architectural designs that is built by the IBM Singapore design team includes the core of a CPUs, the GPU cores, the chips that is based on the accelerator machines, the complex architecture for the multimedia, the images which are fetching with the encoding model, decoding model, receivers, transmitters, communicating with the videos, then the engines. For the audio, it would be the separate engine. For speak synthesis, they are using the SSML, which is a smaller part of our HTML, hypertext markup language. Speak synthesis markup language, they would be analyzing the phonetics, the language translations, the features of the Alexa. So let's play the music, let's play the games, let's set the room temperature to 20 degrees Celsius. So all that frameworks, the reinforcement machine learning models are helping. Then there would be the sensor-based processing engine who would sense it, who would analyze it, that the voice is coming. So voice sensors are there. The physical sensors, the heat machines, the I2C approach, the serial peripheral interfaces with the GPUs, graphic processing units, and the controller area networks for the driverless cars. The I2S, those approaches are embedded together by the design team. So on the design team, they are designing the machine architecture for the reinforcement learning, and these chips would be embedded into the agents, and the agents would be helping to do the predictive reinforcement model of the learnings. Here it includes the one typical example of a chip. So they have the NVIDIA chip, and on to the NVIDIA chips, there are different components. So all those components which are moving the memories to the next levels, the smart devices, the smartphones, the smart watches. So remember the time of 90s, 80s. So IBM was having a mainframe server where it was a room size servers. But now the enforcement learning moved to the smartwatches, the smartphones, and on to the smartphones, the chips, they are doing a calculative approaches. In 2030s, there would be the emerging technologies which are based on the model of a reinforcement as a service, reinforcement machine learning models, reinforcement artificial intelligence operations that would be heaving the data on a real time. So the real time data would be coming on a fly, and on the fly, it would be from the Insta, Facebook, LinkedIn, Twitter, WhatsApp. So these components, they are having a digital models of reinforcement as a service. The data that is floating across any of the ecosystems, the big data ecosystems, the developmental operations that is going with the Dockers, Kubernetes, Ansible, Jenkins, Git operations, they are having the cloud-based servers, the Linux-based instances, and the memory, the RAM, the storage could be accessed, increased on a scalable approach. So 24/7, they would be available, and the reinforcement could be done at anywhere, anytime, with just a single click, just a login, and you log into your portals of reinforcement learnings, where you would be getting their servers of reinforcement servers, which have the cloud-based entities, which has the Linux-based machines doing the RTOS, robotic operating systems, the agent-based OSS tools, and performing all that mechanisms. So let's move further to see how exactly these things have been prescribed in. So every of the things, the world models, for example, any of the object. So there is a chair, there is a table, there is a door. So every of the model would be labeled just like a Google's lenses, Google's some analytical products, the Facebook's metaverse approach, the Netflix big data streamings of the movies, the YouTube real-time streaming of videos. So the world model would be imposed to the agent model. The reinforcement agent model that would be having a sensors, that would be having a chips, that would be using the algorithm approach with the Python machine learnings, with the frameworks of a Django, Flask, building a microservices onto the Dockerized Kubernetes environment, integrating with the physics, graphics, statistical AIs, and embedding that stuff with the sensors, actuators, perceiving what exactly is coming, what the things we are seeing, prescribing, navigating, to view it, manipulations, to see the real-time visualization of a data, how in the real time they are using. So some of the libraries you already have used in the Python, that includes the matplot library for a visualization approach from matplotlib import pyplot as PLT. using the maths library for a precision handling, importing maths, using a statistical library, import statistics. So all that stuff used with the frameworks, with the Googles, they are using the Google's Colab, the research labs, they are using the TensorFlows that has been developed by Google's brain team. Then the Microsoft's CNTK, cognitive toolkits. So IBM's Watson helping with the AI, machine learning approaches, and their design center teams building all that architecture in a real-time IQAC framework with the Jetson Pack, TensorFlows, with the real-time CUDA models, censoring input outputs, actuating, and building the next model that could be deployed on an automational server of reinforcement learning. So they are using the Jenkins for automational reinforcement server model where the test cases need to be built, test, and deployed. So different CI, CD pipelines, continuously integrating it, continuously deploying that stuff, continuous integration, continuous deployment going forward with the sensors, actuators, and moving to the next level of the machine learning's AI approaches to the next entities. So very, very highly performance environment, which includes the USBs, the PCI buses, the camera. Remember, there was a codec camera. Every of the house was having a codec. And the photographic film for this codec, they used to take about a month, 3 months, 6 months. But now our smartphones have a codec, have the camera. There was a tape recorders, there was a radio where the Vivid Bharati, Ceylon, any of the channels, BBC World, that were catching it. But now our smartphones are using that stuff. So technological trends keeps on moving, and on to that movings, they are using a open framework support, open sources of the technologies that is built by the machine learnings, Caffe2, Keras, MXNet, PyTorch, TensorFlows. So the reinforcement machine learning models, they are using the Caffe, the Caffe2, the Keras, the MXNet, PyTorch. So Facebook's model, the metaverse model, is a PyTorch. Google's brain team built up the TensorFlow. IoT reinforcement models going with the Dockerized approach, with the cloud-based greengrass approach of Amazon, with the Amazon's Alexa for the chatbot operations, for talking it, for Apple's, for the Google's assistant, Apple's Siri, using a robotic operating systems ROS approach. So they are embedded to the chips, and onto the chips, the frameworks are doing the next learning of the approach that is going. So in the traditional models, that includes that how to analyze it, how to analyze the emotions, sentimental analysis, error detecting, to forecast the weather, to see the weather predictions, to analyze what is going on to the markets, the fintech companies using the stock analysis, the speak senses, the speak recognitions, and the customer-based recognitions, the customer base needs, CRM as a service model, customer relationship management, and as a service, they are doing with the CRM-based cloud approach of reinforcement using a Salesforce, using a Apex codings, with the Python's coding, with the algorithms that is going with the Google's language, Golang, the microservices that has been built for detecting, recognizing, and using a ML reinforcement learning's approach for detecting the securities, detecting the frauds, preventing detections. So problems need to be studied. So in the traditional approach, what happened? The problems were studying. There were the rules that how the machines would be doing, how the machines would be thinking, how the machines would be evaluating. So they would be analyzing that error. The precision of errors analysis, then evaluation. If everything goes good, so it is going to be a launch. If there are some errors, so need to be seen that, okay, this is a problem. So once the problem arises, then the coder change our algo using some of the algorithmic approach with the KNNs, K nearest neighbors, with the XGBoost libraries, with the layers of the models of the convolution, neural networks, building a deep learning reinforcement models, evaluating it, and then launching it again. So all those predictions are going forward with this kind of approach. This traditional approach was changed to the reinforcement models. Onto this reinforcement models, there was an input message. The message that has been given to the agent. For example, how old are you? So it is decoded. It could be in English language. It could be any of the language. So there were the translators previously, but now these machines replacing the translators. There would be the drivers who would be running a car, but in 2030s, 50% of the US streets would be moving to the reinforcement driverless cars. The drones without a pilot, the aeroplanes without a pilot, and there would be the driverless planes would be flying onto the skies. So encoding the real time of our data, decoding that, putting the next level of iterations, turn 2, turn 3, turn n's. So the success factors, the predictive models could be built with the 99.999% of the accuracy. The errors could be removed and then testing it, deploying it, building it. So encoding, decoding, transmissions, receiving of the signals in the form of 0, 1, 0, 1, how the machines understand it, how the machines understands the logic. They understand it that, okay, how this stuff would works on. So here it comes that how machines helps the humans to learn on. So there are chances that, for example, the humans put an alarm of a 5 a.m. The humans put an alarm at 5 a.m. Then the alarms went on snooze. And his brain says, oh, there is a lots many work. So please wake up. Please wake up. There are lots of the work to do. But our heart says, let's sleep for a while. It is a cozy, beautiful morning, and let's sleep for a while. Snooze the alarm for 5 minutes, and then what happens? After 5 minutes, the machine says, please wake up. The human's brain says, please wake up. But the heart says, it's a cozy morning, let's sleep it. So the approach of our decisions, the machines are taking the next level of the approaches of our decisions. That is going to be a successful factors. And that is a reason the deep learnings, reinforcement learning models embed the career success to the next levels, where the things the brain tells, we need to follow that, not the heart. There could be the case that there are some small delicious dishes and our brain says, don't eat it, don't eat it. It is not good for the junk foods, it's not good for the health. But our heart says, let's have it. So after that, once we have it, there could be the chance we fall ill. There could be a food poisonings, there could be any of the entities. So the decision of the brains, how the brains think it and how the machines think it, that is embedded with the reinforcement learnings. And the logics of studying the problem, iterating it, repeating, practicing. So just like the algorithms, just like the mathematical problems, the statistical problem, providing a solution to the world. So some of the companies, Uber is not owning its own cars, but it has a bigger MNC company, multinational, dollar price revenue generated. So there are n number of the examples. So couple of companies, they do not have its own cafes, McDonald's, but the franchisee models, they imposed it, they iterated it, repeated it, and then they trained the machines. The algorithms, the solution, inspecting a lots of the data, understanding that problem, and inspecting to build that solution model. And this is how the machines are helping. They are building the whole of the stuff that is required in the next level of the models that is there. So let's see it, how this interaction of a environment and an agent, how the agent and the environment talks to each other. They are performing the action. The reward is awarded by the environment. For example, we wake at 5 a.m. We went to the gym. What is the reward? Our health is good. So similarly, there is a approach that we need to analyze it. The agents would be taking care of every predictive actions that we are putting into the outer world model. So the next level of the algos goes is with the image recognitions that, okay, this is the celebrity's image. This is an image where the reinforcement neural models with the convolutional techniques, with the object detections, with the semantic segmentations would be moving on and using those entities with the OpenCV models. There it comes, the latest releases from this OpenCV, computer visions. You could download the kits for the Windows entities and it would be downloaded. For the iOS, it would be downloaded. For the Android, these computer visions techniques that is going with the next level of approaches with the computer visions, reinforcement learning with how the image would be classified. What would be the entities that would be moving on? So detecting the object, applying a region-based approach using a semantic segmentations that, okay, this is particularly a dog, and then applying the reinforcement learning. So here we are seeing the environment, and after seeing the environment, there are different agents. On to that environments, we need to observe it. The agent would be observing, selecting that action policy, what to do, how to do. Then it comes the actions, the reward penalty, how to update it, what would be the approaches. So seeing the environment, seeing the agent, observing that environment. If there is any of the issues, oh, the minus 50 points would be deducted. So the action-oriented streams, the action-oriented approaches. Then seeing the reward, putting a bar rewards. If it is a bad approach, the points would be deducted. Analyzing that whole things that is moving on. So the cards seeing that entities, analyzing that entities, and then studying the real-time data, real-time problem, applying the trained machine learning's algorithms approach, evaluating the solution, and launching that data. Analyzing it, seeing it, putting that data into the real-time approaches. So training it, after applying a training sets, labeling that entities, putting a instance, putting a labels that, for example, in our Gmails, there are lots of the spam mails. So they are applying a filter. Some of the words we are putting as a wrong words. So it is auto-correcting, the auto-spelling corrections. We are saying to the Google Assistant, please call to this number. We are using the Google's map. So some of the approaches that how exactly the things would be labeled on, and on to that labels, the new instances would be used for a classifications, and after the classifications there would be the values, regressional values, the feedback that is coming from the X and Y comparisons, the predictions of the prices versus some of the latest features, the house predictions, the disease predictions, diagnostic of the some of the stuff, the drug research, all that models is putting it, studying that problem, analyzing a machine learning's algorithmic approach, and on to that approach, analyzing it, using errors, checking the errors, trying to troubleshoot it, evaluating whole that entities, and launching that entity.
Excuse me, sir. Sir.
So here, if we talk about the entities where we are putting the automatically adapting to the environments. So using the updational approach, using a machine learning's approach for evaluation of the solution, launching it, providing a different training sets, dividing the entities, the boundary sets into the smaller entities, dividing the training sets so that the reinforcement learnings, the online learnings could be analyzed on the data on a fly. So it includes the data that it is coming on. We need to train it, test it, train it, test it, and then the reinforcement algorithm, the codes need to be evaluated, then launched, and the data on the fly that could be coming from the different IoT devices, that could be coming from the devices that would be floating in, launching, evaluating, and running the next learning of the models. So we are chopping that lot of our data, studying that problem, analyzing that problem, cutting this data into the smaller chunk of the chop pieces, then applying each and every algorithm to predict that models using the layer by approach of TensorFlows, the Keras, visualizing with the Matplotlib, with the Seaborns, analyzing it, predicting that use case, then evaluating the particular solution to handle, to analyze that errors. So every of the instance is divided as per the feature values, as per the agile dollar values, the revenue cost for the companies, and then applying the model-based learning for their features. The feature one, the feature two, every of the boundary sets need to be divided, need to be imposed onto that entities. So this is a little architecture for the real-time state investments. That is how the upstream components, the district data, the components, that how the investment analysis, investment prices would be indicated. So data would be coming from the upstreams, the distinct prices, and analyzing with the investments analysis to the next levels. Then applying some real-time approaches that is going on to these models. So mathematical algorithms, the binomial theorems, the Gaussian ratios, the Poisson ratio, the entropy models, means, medians, variance, that could be imposed in. So how exactly the means could be calculated for predicting the errors? So this is a exemplary set that they are the floods where the data sets need to be loaded, analyzing it, predicting it, and similarly, any of the data sets, they are calculating the reinforcement models. Seeing the decision functions, checking it, how exactly the pointer values could be added on, could be removed on. So that is the entities that is going for the different data sets. So here comes the agents, the robots, where the dynamic environment of interacting the environment, taking a very best actions using a simplex, reflex agents, model-based agents, the goal-based agents, utility-based agents. Doing those entities, putting those entities, and interacting with the machines executing the actions onto the environments. That what would be the rule, what would be the state, what exactly would be the actions. So reflex agents executes some of the operations by observing the environment of outer world. What exactly is outer world going on? How to observe it? What would be the state? What would be the pre-programmed action that we would be putting onto the environment? So continuous cycle, observing the environment, taking a respective action, observing the environment, taking a respective actions. So predefined state, predefined action rules have been put up and reflex agents would be taking care. Then comes the model-based agents who is analyzing the history of the past observations. For example, a daily routine, Monday, it is at 5 p.m. one is taking a milk. Tuesday, taking a milk at 5 a.m. Wednesday, taking a milk at 5 a.m. Thursday, taking a tea or a coffee at 5 a.m. So the machines would be observing what is the itinerary, what is the repetitive actions, and then calculating it that, okay, once come to the office at 10 a.m., goes to the home at 7 p.m., then going for dine out with the family at this time, then sleeping at 10, 11. So that could be the itinerary, the repetitive observations. So machines would be analyzing those actions, seeing how exactly the environment is behaving, what would be the past, present observations to predict, to state, to see it, how the actions and the agents would be behaving it. So this is our approach where the reward would be put up. Then the goal-based approach. What is the actual results? What are the results? What is the goal that would be provided it? So predefined rules. The past, observing it, seeing the states, analyzing that state, seeing the observations, and then comes the utility. What exactly is the utilities and those rules, those observations that need to be evaluated, that need to be achieved? So this is the utility based. Then comes the intelligent agents. So the robots, the agent machines, the reinforced machines, they would be setting some action items. For every of the positive, there would be the reward points. For every of the negatives, they would be telling that, okay, the robot would fall down. Then going to the destinations, learning from the approaches, relearning, learning from the past mistakes, putting a rewards, the positive rewards or a negative reward. So how the machine would be putting it, analyzing from the past feedbacks, observing all that data, and intelligent agents comes into the pictures. So some of the reinforcement models, the terminologies that are used comes regressional models, the multi-class, putting a model size, how much trainings, how much number of passes that could be approached in. Then regularizations of the machine learning's quality models. So some terminologies, the goal-oriented approach, regressional approach, the multi-class, the binary, the model-based, and the number of passes that would be putting up. So let's now see some of the reinforcement models that is used onto the cloud models, onto the how exactly they are using onto the different products, and these products have been came with the real-time industrial use cases. So the first model comes the image analysis. In this reinforcement model of the image analysis, there is a picture and it is detecting, it is seeing the object. What is the object? What is the category? Is it a beach? Is it a coast? Is it a sea? So what are the predictions? There could be the prediction that there could be a dolphin. There could be a sea creatures. There could be the tortoise, the turtles, the beautiful fishes, beautiful sea creatures. There might be a good nature, right? And the prediction is 99.9%. So what is the confidence? What would be the category? What would be the labels? Then comes the facial analysis to detect the particular face. The smiling face adds the confidence to the next level. The aviators, the goggles, adds some more confidence to the demographic analysis of a face for a sentimental captures and the pixel values that would be there. Then comparisons. So there could be a celebrity comparison. There could be an image to image comparisons, and all the digital data we are putting onto the WhatsApp, Insta, Facebook, the post, the profiles that would be putting up. So recognizing it, comparing that faces. If the first face is equal to first, is it the second is equal, yes or no, true or false? The conditions need to be analyzed in. So all those recognitions comes with comparing of the faces. So the next levels comes with a very deep learned enabled reinforced cameras. So there would be the videos would be reinforced. The video cameras, they would be predicting the analysis. Then comes the deep lens enabled cameras, how exactly the camera, the status, the Wi-Fi status, the power button status, the SD cards, the HDMI cards, the power supplies, they would be using that models. Then comes the techniques of a reinforcement learning to the natural languages. Everyone is speaking the different languages. In France, it is French. In Japan, it is Japanese. In India, it is English, Tamil, Kannada, Telugu, Hindi. Couple of the languages that have been floated in. How these machines would predict it, how they would be applying the stuff. So they are importing the NLTK toolkit, import NLTK, importing that toolkits, putting that toolkits, understanding the natural language, understanding that way, how the keywords What would be the sentiments? So Twitter captured the sentiments that, okay, Obama would win, or it would be the Trump. So capturing the sentiments, seeing the analysis of the posts, exploring each and every data, and putting the confidence levels in the form of a data types, list, tuples, dictionaries, putting our API returns with the listings, titles with the JSON-based entities, putting a comprehend, keywords, sentimental captures, topic modelings, and providing that whole kind of a stuff. Then capturing list-based approach, the JSON-based approach, the API-based approach, that is the entities. Then checking the confidence, putting a list that, okay, these are the parameters, these are the features, and putting it. So life is like a speech. Speaking just like a SSML, speak synthesis markup language. We would be speaking up, it would be writing. The robots would be teaching up the papers, the examinations. There would be writing up or speaking up, it would be definitely writing it. To speak synthesis is going on to the reinforcement learnings, where we have a couple of live examples, just like Alexa, the poly, seeing the tags, checking that tags, seeing the phonetics, analyzing that phonetics, applying the models that is there. Then the conversationals, we could speak up. We could talk the reinforcement models. We could talk to these agents that, okay, where we made the mistake, how the decisions could be improved to the next levels, how the successful careers could be built on with the predictive models. What would be the predictions? Predicting of the diseases, diagnostic predictions, fraud predictions, sentimentals predictions, every of the stuff, the conversational engines, the conversational bots would be helping it out that, okay, the intent-based, goal-oriented based approach that is going with the operational bots, operational informational bots, the chat bots would be talking it. Remember the days there were the past, there were the people sitting it onto the office, but now every of the site, once we open up, every of the website, once we open up, then here it comes the pop-up. Then it comes the informational and the applicational bots. There comes the Amazon's, the Facebook, Amazon, Microsoft. They have built the architectural designs for building, deploying the models. So fully managed approaches with the machine learning approaches, using the not the 10x performance increase, but it is the 100x performance increase, training it, building it, using some of the algorithms, the linear learner, the factorized machines, the XGBoost, the image classifications, the K algorithms, the principal component analysis, the neural topics, deep models, and the text models. So these stuff increasing the power of a time, productive stuff implementing the real dollar value to the company, they are increasing. If we talk about these stacks, that is a stack of the AI, ML, RL, DL stacks. So these are services, the speak services, the poly, the vision-based, the language-based models have been developed. The platforms where all those platforms could be used in. The frameworks, that is Apache's MXNet, the TensorFlows, the Caffe, Cognitive, the PyTorch. So all those AMIs, they are built, the Amazon machine images, the reinforcement images have been already built on. They have the Dockerized containers. They are using the NVIDIA's GPUs, the CUDA-based libraries, the TensorFlow-like libraries, the frameworks that has been put together. Once these models are used for the customer-based services, so that is the approach comes with the AI as a service models, with the machine learning as a service model. Anywhere, anytime, anywhere, anytime, and you would get a notable success. Anywhere, anytime, and you would get a notable successes. So the companies, just like a Netflix, Zillow, Zip, Reuters, so everyone got the notable successes. So approaches with the real time, with the objects and the scenes, the facial detections, facial analysis, image moderations, where they could use it. So the reinforcement learnings could be imposed at every part of a time. Every place of the industries are using these models. So how to build the logics? What would be the libraries that would be used? Which languages, which tools you would use for the 4.0's revolutions that it is moving on. So selecting, analyzing the image moderations, seeing, uploading that pictures, seeing, checking the object. If it is approved, the picture is approved, so it is appropriate content. If the picture is not approved, it is inappropriate content. So the detection, the manual reviews, how the exact reviews could be done at. So there would be the architectural designs that, okay, the video encodings, decodings, and then putting that entities to the next level of the entities. So a couple of sports to the languages, to the voices, whole of the text conversions, the voice-based interactions, the power-based Alexas, the text-based stuff, and the enterprise connectors, that is the entities. So with that, you could build your own chats using these services, that is a service stacks. You could deploy your codes with the intent-based approach and other entities. So the architectures, the functionalities with the message queues, transfer protocols, the IoT based with the AWS services, the Amazon cloud, the Microsoft's cloud Azure, or the Google's cloud that could be integrated with the DevOps tools. Using the IoTs, detecting anomalies detections, and analyzing with the analyticals. So in the real time, the data would be streamed. The IoT device, it would be streaming that data, putting analyticals, putting a streams using a DynamoDB, getting the dashboards, seeing the alerts in a real time, getting those alerts, analyzing it, seeing it, and testing that entities. So real-time powered reinforcement analyticals. So for whom this approach is used in, so who want to inquisitors, who want to adopt it, and who are the experts. So before we wind up for the today's stuff of my side, any questions? Anyone have it? So please ask it. If there would be any of the questions, I would be happy to answer your questions if there is any of the questions that are there.
Yes, students, if you have any queries, you can ask. Hope everything is clear for everyone.
Okay, so thanks a lot all.
Yes, sir.
Stay safe.
Thank you so much, sir. Then
Okay.
we'll move on to the
Thanks
next.
Yeah, thanks a lot. Thanks a lot.
Thank you, sir. I think we can all agree that the session was resourceful and intriguing. Learning and understanding more about reinforcement learning surprisingly was very interesting. On behalf of all students, I'd like to thank you for that. Before we conclude, I would like to invite Program Director of Computer Science Department of SCAS, Ms. Chamber PJ, for word of thanks.
Thank you. Good morning, one and all present here. The esteemed chief guest, Dr. Aman Kumar, respected Executive Director, Davis Chingnianan, respected Principal Matthew Paulukan, HOD, Savita PC, and all the participants. It is such an honor for me to get an opportunity to thank you all the dignitaries on behalf of the Computer Science Department, Sahrdaya College of Advanced Studies. I would like to express my gratitude to all the esteemed delegates of the webinar for their presence and the contribution to make this webinar a great success. I extend my gratitude to our esteemed chief guest, Dr. Aman Kumar, to take out his time, his busy schedule to grace this event with a complete overview of reinforcement learning. Thank you, sir. I extend my gratitude to our respected Executive Director, Dr. Davis Chengniadan, for inspiring and encouraging us with your words on a special day. Thank you, Father. A special thanks to our respected Principal, Dr. Matthew Paulukan, for providing immense supports to make the webinar a successful one. Thank you, sir. I extend my great gratitude to Dr. Manish Kumar Jain, the training head Technova, for introducing today's chief guest to our session. Thank you, sir. I extend my gratitude to Mr. Ranjit M, CTO, and his team for organizing the webinar and the technical support throughout the session. Thank you, sir. I extend my gratitude to Ms. Sabita PC, the head of the department, and all other staffs and the students for their kind support. I must thank the organizing team Technova for working hard for the past few days to make this webinar a successful one. Thank you everyone once again for making this event a great success. Thank you. With this, we wind up the wonderful section. Thank you everyone for joining us. Thank you once again. With this, we are concluding our session. Thank you.